Hi everyone, welcome back. Today we are solving reverse bits. So in this problem, we will be given a number in decimal form and we want to reverse the bits of the number that we are given in its binary form, but we want to return it in the decimal form. So in this example, we have this number. This is a binary form. We reverse this numbers and then we return its decimal form. And same for this example. This number will be represented like this in binary. Reverse the orders and this will be the number in decimal. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can first initialize the result variable to 0 and then we will iterate from index 0 to 31 and then we will use this formula to get the digit number. So it will be the number input that we have and then we will right shift by however many index depending on which iteration we are on, and then we will do the AND operation with 1 because if the digit is a 0, then if we do AND operation with 1, then we know the digit number is 0 because 0 and 1 is 0, and 1 operation with 1 will be 1. And the reason this works is, let's say we want to do compare with 1 and then our number is blah blah blah. Let's say we're looking for this one, right? So 1 will look something like this, and if we're looking for this, then we will shift to the right 2 times, meaning this will be gone, this will be gone, and we just compare this. All these are irrelevant, so to get the digit, we know that the digit will be 1 here. And 0 and operation with any number will be 0, so all these digits will be 0. So that is why this formula would work. And once we have the digit number, we will now shift back to its reverse position. So now we will left shift by 31 minus the index to shift it to the reverse position, and we do that so we can place the number at the proper digit and then we can add that to the result. And finally, after finish all the iterations, then we can return result. So let's go over this example real quick. So this is the input number and this will be how it is represented in binary form. So we will start at index 0. So we will use this formula to get the digit number, which is 0 because we shift by 0 digits and we compare with 1, so that's 0. And we will use this formula to put it at the proper position here. Now keep in mind, this will be in decimal form when we add it to result, but I will show it in binary form just so it's easier to understand. But when we code it out, we don't have to worry about the conversion. Just know that when we solve this, it will be in binary, and when we add it back, it will automatically shift to decimal. So we are index 0, so I would be 0, and it is 31 shifted to left, so that's why we added here. And let's move on to the next one. Index 1 would be 0 here, and index 2 shifted by 29 over here, and I will speed through the rest of the digits. And finally, this will be our result. In case you're curious, this will be the number in decimal form. So the time complexity would be O of 1 because we will be iterating 32 times no matter what, since we are given a 32-bit integer. So no matter what n is, it will be set into 32 bits. So we will do 32 iterations every time. So the time is constant and the space is also constant, because the size of these variables will not depend on the size of the input. So now let's get to the coding part. So first we'll initialize result to 0. Now we will do the iterations for I in range 32. And we will set up the bit variable to n, right shift I, and 1. And now to put it in the reverse position, bit left shift by 31 minus I. And finally we can return result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any more comments or questions, feel free to leave them in the comment section, and I hope to see you all again soon.